Mr. Dewick, I didn't know how to do number 15 from the homework yesterday. It's a tricky one. If you go to my website, what's my website? And if you click on Physics 12, and if you click on the screencasts, during Flex today, I did put a link to a YouTube solution for number 15 if you're stuck. And remember, I put some for lesson 5, number 9, lesson 5, number 3, lesson 4, number 13. These are the ones that kids have asked me over the years. So if you're stuck on some of the nastier ones, you can look there. If you're still stuck, I'll absolutely help you as well. I don't mind doing that, but this is so that when you're doing the homework on your own, you can kind of figure it out. Today is called Advanced Inclines, and it's weird. I've said this before. I find for many students, the tougher I make the questions, the easier they find it because they figure out how everything fits together better. So, we're on inclines. So we're thinking we'll put in mg, we'll pause, we'll turn it into parallel and perpendicular components. Let's look at example 1. How much force is required to pull this mass up the frictionless ramp at a constant speed? What 2 words should I make note of here? In fact, I might even be tempted to underline them. They're ding, 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 pay attention words. Because if we're at a constant speed, then Keegan, what's our acceleration exactly as a number if we're at a constant speed? Which means the forces are, I'm looking for that starts with letter B. I'll remember that. What force, Alex, is this asking me to find? Can you all see it? What's it asking me to find, do you think? No. Well, eventually, I think it's asking me to find tension. Like, what force is required to pull this up? I think it's going to ask me to find tension. I'm going to keep that in the back of my mind. Alex, this is a job for a free body diagram. What are the forces acting on this mass? Get the obvious one. Okay? So, like that. Now, I've had a few people that have told me that they're kind of struggling with the diagrams. So let me be really fussy here. When I'm talking about drawing a perpendicular component, sorry for those who are at home with YouTube, what I'm really saying is, look, pause, we're going to do a component, put the mg on the pointy side. If this is the ramp, my perpendicular component is going to form a right angle with this line. Not like this. If you're drawing it like this, nuh-uh. If you're drawing it like this, or even like this, nuh-uh. You want your perpendicular component to go through the ramp at a 90-degree angle to form a perfect 9, as best you can, eyeballing it, or if you need to, even use a ruler if you need to. So, I usually switch colors because it's a component and I do it in a dotted line. Should I go further, or is that far enough? Okay, when am I going to stop? Well, I want the other line to be parallel. So, the other line needs to be parallel to the ramp. So I'm eyeballing, I go maybe 1 dot further. There is my MG perpendicular, and there is my MG parallel. Oh, and then Quinn, color, 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 color. Is that okay, Alex? What else? Later. How big? Again, not the same size. Don't draw that. Is it sinking into the ramp like quicksand? No. Is it flying off the ramp like Superman? So there's got to be a force pointing straight. Oh, this is not a dotted line. This is not a component. This is an actual force. It's going to be the same magnitude, I'll eyeball it, as mg parallel. And it's going to be also as a perpendicular. And again, Lena, it's going to be a right angle right there. Okay? What else? Tension. Which way? Up the ramp. Is there friction in this question? Okay. Who's winning? It's actually a trick question because what's my acceleration exactly as a number? So technically it's a tie. And you were right. When I asked you, Mr. Duke, I said, what force are we trying to find? I was hoping you were going to say tension, but you went 1 step deeper, I think. I would like to think that you said, actually, Mr. Duke, tension is going to equal mg parallel, because it is. right? Because it's a tie. Now, really what I could have done is this. Tension minus mg parallel, don't write this down, equals ma. But if we're at a constant speed, what's a exactly as a number? So I could replace that a with a 0. But what's m times 0? What's anything times 0? And so I could do that. But then what? I would just plus this over to that side, and I would end up right there. But I think most of you are good enough that you can just get right there without all those intermediate steps. mg parallel, 2 lines. Really? Jan had to help you with that? Wow. I don't think you did. So it's going to be M, 7, G, 9.8, sine 40, which is what? $44.1? I agree. Units? It's a force. Yep. Gotta be honest, I would consider that a sea level question. Okay? What if I wanted to kick this up a notch? Jan, what's B want me to find since you're so good at this? What's changed in B? So, what force do I need to add to my free body diagram? Use not a force. Friction. Okay? So I'm not going to redo the whole thing. I'm now just going to continue to mark this up. Jan, which way is friction going to be pointing? Up the ramp or down the ramp? Why? Which way is this mass trying to slide? Mass is trying to slide down the ramp? And so because we're sliding it up the ramp, friction resists the direction of, resists sliding. And so it's going to be down the ramp. I'll do it in black just so you can see we've added it. Okay. I think it still wants us to do a constant speed. So still technically, Jan, when I say who's winning, it's a trick question. It's a tie. But folks, can you tell me what does tension have to equal this time in our equation? I disagree. It doesn't equal friction. Both, Lily, mg parallel and friction. It's having to cancel both out. Is that all right? Okay. Jan, friction is what times what? Yep. Straight from your formula sheet, which I'm sure you have in front of you and could have looked at and got that from, right? So it's going to be mg parallel plus mu times the what? I don't know the normal force. Oh, but look. I know the force is the same size as the normal force from my free body diagram. Which force is the same size as the normal force in my free body diagram? Yep. Good. Okay, let's do the trig part now, Jan. G, 2 lines. So it's going to be G sine theta. I'll do a generic one, and then we'll put in our numbers. Plus mu m g. Oh, perpendicular, which trig function? Do you know? Of course you do. Oh, why did I write perpendicular? Cos. Do the g's cancel here? No. Do the m's cancel here? No. There isn't an m or a g in everything. In the tension and in the there's no m, there's no g, which kind of makes sense. A bigger mass, you'd have to pull harder. Okay, let's plug in our numbers. I've scrolled down, Jan. What was M? 7, was it? 7. G, 9.8. Sine, what was theta? 40? Plus 0.65 times 7 times 9.8 times cos 40. Jan, what'd you get? You know what? I can probably just backspace and just then add the 0.65 times 7 times 9.8 cos 40 without having to retype the whole silly thing. Yeah, I can do that. Totally works. And it's plus. What'd you get? $78.3 if I go to 3 sig figs. Okay. And newtons, it's a force. B, I would consider much more like a B level question because there's friction included. That to me would be more fair game on a test. Turn the page. Yeah, Madison, it's kind of an Atwood machine with a ramp. No biggie. Two objects are connected as shown. M1 is 12, sits on a horizontal surface that has friction of 0.17, a coefficient of friction of 0.17. M2 is 9.8 kilograms. I regret this question. I shouldn't have made it 9.8 because what'll kids confuse the 9.8 mass with? Just gravity. Is that gravity? I should have put a different number in there just so you don't confuse it. I'll have to change it for next year. This is what happens when I'm making up numbers in a hurry. But that 9.8 mass is not the same as the 9.8 meters per second squared gravity. It's just a fluke. Okay. Claudie, what does this want me to find? Is there a part B, find the tension? Oh, there is. Good. Okay. Talk to me. What? Oh, free body diagram. Oh, you're already getting it to me. Good. Okay. Sorry. On M1, what are the forces acting on it? So M1, G, which is I'm sure what you meant to say earlier, right? What else? And I think it's the same size as M1G. I'll call it normal force number 1 to go with mass number 1. What else? By the way, do you see, Nick, I think this diagram is going to be a little longer. I have a tough time saying this question's tougher. It's just more forces, and be more careful when you do your winner minus loser equation. Claudia, keep going. What else? Yep, what you're feeling right now. What else? Which way? Yeah, because there's no way a box on its own spontaneously would start crawling to the left, lifting this up the hill. There's no way. So friction is this way. What are the forces on M2? Get the obvious one. I'll draw it nice and big. I'll go through the ramp so I have an extra little 90-degree angle for reference. And that's going to be, I agree, M2G, pause, components. I'll switch to blue since I'm doing this in red. So I'm going to go at right angles. I'll stop right about there. M2G perpendicular. M2G parallel. Color, color, color. Color, color, color. Okay, I've taken care of my components. What else? Normal force number 2. Same size as mg, like that? Oh, no. It's going to be also at right angles. In fact, the word normal means perpendicular to. That's why they call it a normal force. It's not called normal because it's like normally there or anything. It's another word for 90-degree angle. So, Fn number 2 to go with mass number 2. What else? Yep. What else? And you know what? I should have switched back to red so I'm consistent. So I'll do that really, really quickly. Quinn, what did you say? Friction. Is there friction underneath mass 2? I think they said mass 2 is on a friction. But could we handle it if there was friction? Yeah, there'd be one more force. I just added that so the equation wouldn't be so long. I added the phrase frictionless surface. Or sometimes what you'll see is they'll put it on wheels to suggest there's no friction because it's a car, a perfectly frictionless car. All right. Claudia, who's winning? That's a good question. Which way do you think this whole thing is accelerating? To the right and then down the, which way do you think is winning? To the right and then down the ramp. This is what's causing this whole thing to move, M2G parallel. It's the winner. So again, I'm going to walk along the rope. Anything that ends up down the ramp, winner plus. Anything that ends up the ramp, loser, minus. So I think it's going to look like this. M2G minus tension. I forgot to put a T there. There we go. Plus tension, minus friction. And you know what? I could have called that friction force number 1 to go with mass number 1, just so I don't get silly mixed up. Do I need to put M1G in this equation? Is it minus M1G? Have I made a mistake? I have an answer.
Why would there be friction on this too as well?
What word did I underline? Okay. We mentioned that, but you were busy chatting. I said that I could totally have done friction. It would have made the equation longer and not much tougher. Often they'll let one surface be frictionless, or you'll see they'll put wheels on this to suggest it's a car or something like that. If you look at the ultimate review, you'll see, oh, there's a fair number where it's a little car. They figured if I can handle one friction, I can handle 2 frictions, but save myself some time. Is that all right?
Yeah. Good,
shut up. Here we go. So I think that equals Clody M all A. You having a good day? Clody, relax. Lose a little tension. Oh, always so nice to lose tension. What are we asked to find? I might even be tempted to go on that line already. So let's see if we can break this up a little bit. It's going to be M2G minus, what will I write instead of friction? Friction is what times what, Jan? Friction is what times what? Mu. So I would go mu times, oh, I don't know the normal force. Oh, but look. I don't know the force the same size as a normal force. Which one? I don't think, oh, yes, mg, not m1g. Good. Anything else? Divided by m1 plus m2. I was going to stick the component in there. No. There's no friction on that one. So nice and easy. Yeah. Did I make a dumb mistake?
Yeah. M2G parallel.
Ah. M2G parallel. That's what's down the ramp. Is that better? Yeah. Okay. Oh, and up here should have been parallel, Mr. Dewick. Right? 2 lines. So it's going to be M2G sine theta minus mu m1g all over m1 plus m2. Let's see if I can fit the numbers in here. You know what? I'm going to go to one more line. A equals, what was m2? What was m2? 9.8 times another 9.8 sine 42 minus, what was mu? 0.17 times 12 times 9.8, all divided by 12 plus 9.8. There's a bit of a built-in error check. If there was no ramp and this mass was dangling in mid-air, what's the fastest it could possibly accelerate under the influence of gravity? There is a ramp and it's being held back. You're going to get an answer less than 9.8, I can tell you that. Come on. Let's see, bracket 9.8. You know what? 9.8 times 9.8 is just 9.8 squared. Sine 42 minus 0.17 times 12 times 9.8. Close off the top, divided by bracket 12 plus 9.8. Did you all get 2.03079 and change? So 2.03 meters per second squared. Valerie, what's B want me to find? Tension. Which mass would you probably choose to find tension with? I think so. What's my equation for M1? Which way is M1 accelerating? To the? M1 is accelerating to the left? And so M2 is getting pulled up the ramp? Which way is M1 accelerating? To the right. Who's winning on M1? Who's the loser? Sarah, did you see that? I said, who's the loser? And she looked at you. I think the next volleyball practice, work the ankle. Right? You got it. Mal, tension minus, good. And I'm going to go mu M1G. Since I have an expression for friction sitting right here, I just lifted it right from this section of the equation and got lazy. That equals what? M1A? How would I get the T by itself? Yeah. Tension is going to be M1A plus mu M1G. It's going to be M1, which was 12. I'm going to write 2.03, but I'm going to use my answer button, plus 0.17 times 12 times 9.8. 12 times answer button, plus 0.17 times 12 times 9.8. And I get 44.4? Yeah. Hey, what else can we do? So here is half an Atwood machine and half a ramp. An Atwood machine with a ramp. The real question here is, how would you figure out which way this system is going to accelerate? See, the problem is this. Let's suppose, don't write this down, just look up. This is 9 kilograms, and this is 1 kilogram. It seems to me that 9 kilogram dangling straight down is going to easily pull the 1 kilogram up the ramp. But what if this was 10 kilograms? Ooh, what if there was also friction? I need to figure out which way friction was going to point. How can I figure out which way this system is going to accelerate? Well, one method is to guess, and you'll know you're guessing wrong if when you solve for A, you get a negative acceleration. Then you got to quickly go back and you make your winners losers and your losers winners, and you might have to flip friction. That's one way, and that's perfectly acceptable. But a better way is to do a free body diagram. What are the forces acting on little m? Quinn, get the obvious one. Little mg, then tension. Big mg, cause, components. Big mg perpendicular, big mg parallel. Normal force, tension. And friction if it was in there, but I wouldn't use friction yet. Here's the question. Can you see what the real tug of war is between? I'll give you a hint. One of them is little mg. What's the other tug of war force here?
MG and MG parallel.
Big mg parallel. The real tug of war is between that and that. And so if you want me very quickly, before, I would still do a free body diagram, but then before I dove in, Lily, and even before I put in friction, because if there was friction, if this is sliding up the ramp, which way is friction pointing? Down the ramp. What if this is sliding down the ramp? Which way is friction pointing? So I would hold off. I would say, I got to put in friction, but I don't know which way to put it. I would just compare little mg to big MG parallel. Or as I like to think of it, big MG two lines. Or as I really like to think about it, big MG what? Sine theta. Crunch those both quickly on your calculator, and Lily, whichever one is bigger, that's the winner. You can't crunch these ones yet because I haven't given you numbers. But let's do one with numbers. Okay? I like example 3. I like example 3. Example 3 is a nice question. See, this is a bit tricky because 5 kilograms straight down, 8 kilograms at an angle. Well, 8 kilograms is bigger than 5, but it's at an angle. I don't know which one is bigger. I don't know which way it's going to accelerate. So, free body diagram. What are the forces acting on the 5? M1G, tension. What are the forces acting on the 8? M2G, pause, components. M2G perpendicular, M2G parallel. Normal force number 2 to go with mass number 2. Same size as M2G perpendicular. Tension. Madison, which force am I missing? Loud and proud. Because there is a coefficient of friction. Don't put it in yet because I don't know which way this is sliding. So let's not forget to put in friction. We're going to do that in just a few seconds. But first, what's this tug of war between that bad boy and that bad boy? So on your calculator, can you quickly crunch M1G? 5 times 9.8? What do you get? 49? And then quickly crunch M2G parallel, M2G two lines, M2G sine. 8 times 9.8 sine, how big is angle theta? 30. And I get 39.2? Which force is bigger? M1G or the M2G parallel? Who's winning? Which way is the 8 kilogram accelerating? Up the ramp or down the ramp? So which way is friction going to get pointing? There you go. I'll call it friction force 2 to go with mass number 2. You see how we put all that together? Okay. So here's my question, Lena. Who's winning? You're right, but I couldn't understand what you said. But I'm pretty sure you're correct. M1G. And so let's walk along the rope. Anything that ends up pointing down, once it gets to that side, is going to be winner plus. Anything that ends up pointing up, once it gets to that side, is going to be loser minus. So here we go. Winner minus loser plus winner minus loser. Are there any other forces along the rope? Nick, you're correct. It equals M all A. Nick, how's your day going? Relax. Yeah. Ooh. What about M2G parallel? I missed that. It's an easy one to miss because it's not sitting up there. So I asked, were there any other forces on the rope? Yeah, there are. There's also minus M2G parallel. See it, Nick? And that's an easy one to miss because it's down there, but it's definitely along the rope. Got that? Yeah. Equals M all A. That's better. Oh, Lena, what are they asking me to find? I'd probably do that on that line right away. All right, let's carefully do our trig. It's going to be M1G minus Jan. Friction is what times what? I don't know the normal force. Oh, but look. Another force the same size as the normal force. I think it's going to be M2G perpendicular. Yes? Which trig function is that one going to be? I think you know. That one, how do you know? 2 lines is sine. Mr. Dirac, perpendicular is technically, yeah, shut up. 2 side-by-side lines is sine. There's limits to what gimmicks I can come up with, okay? I get it. So it's going to be M2G cos. And then, Nick, now we have M2G parallel. Which trig function is that going to be? Yes. All over M1 plus M2. Common mistakes. It's amazing how often kids forget the second G or the third G because they've written so many G's, their brain has kind of checked off, look, I took care of gravity. Just be really meticulous. You can see it's easy to make mistakes here. A is going to be M1. Let's see if I can get this all on one page. Not quite. Let's do that. 5 times 9.8 minus was it 0.05? Yeah. Times 8 times 9.8 cos 30 minus 8 times 9.8 sine 30 all over 5 plus 8. Dividing by 13, it's going to be a yucky decimal. Let's see, I think that looks right. Did y'all get 0.4927061.859? 0.493, if I go to 3 sig figs. Lily, what does B want me to find? Which mass would I definitely use if I was trying to do myself a favor and not have to do a whole bunch of extra work? What's my equation for M1? Which way is it accelerating? Who's winning? Who's losing? Equals M1A, because we're just writing an equation for that one, right? M1G minus tension equals M1A. How will I get the T by itself? Swappy dance. And so it's going to be M1 5, G 9.8 minus 5. I'm going to write 0.493, but you know I'm using my answer button. Make sure I did that right. That looks good. And I get 46.5 newtons. Whew. Okay. I would consider this B plus A minus, which leads the obvious question, right? What would I consider A plus? Lena, I'm sorry, but Atwood Machine with a ramp and a missing mass! Because B says find M2. Okay. Zana, question? We're good? So we'll finish with this. We'll finish with this on Friday. I gave you a bunch of questions last day. I know you're still working on them. If you're wanting to get a head start here, absolutely to me, number one, except you can cross out B. I usually skip finding friction because I'm teaching you to do these whole things algebraically in one step, so I'm too lazy to find something in order to find something if I can get straight there. 2 is good. Take a look at number 3. This is tougher than I'm going to ask. An Atwood machine with 2 different ramps with different angles. It's not much tougher. It's fair game, but it's just so much writing. I'm going to give it to you. Oh, but it's a missing mass question. Ooh, I haven't done that. Well, I kind of have. Okay? 4 is good. Now, 4 is saying it's at rest, but if pushed slightly, it will begin sliding. What you'll need to do first is figure out which way friction must be pointing to hold it at rest, and then you can assume A is 0 for the rest of the question because it hasn't started sliding yet. Your hint for number 5 is I think you're going to want to take this 120 and find its parallel and perpendicular components. And unfortunately, my stupid trick of 2 lines won't work for that one. You'll have to do a little trig. Star next to it, that means, again, it's tougher than I'm going to ask. Skip 6. 7, I like number 7. I like number 7. I like number 7. 8 is good as well. Skip 9, or as I like to say, 9. Skip 10. Skip 11. There is no 8? Yeah, there is. It's the one that comes right after 7. Pretty sure there's an 8. Right? 0 wearing a belt. Call it an 8. 12 is good. 13 is good. You'll get a fair bit of time to work on this tomorrow. I'll finish the lesson off tomorrow. Or sorry, Friday. I'll finish the lesson off Friday. I may start the next lesson. We'll kind of play it by ear.
What if he's watching?